We're now going to look at acids and bases in another aspect, and that is what is the difference between a strong acid or base and a weak acid or base, and how does that differ from what is a concentrated acid or base or a dilute one. As we've talked about before, an acid is something that's a proton donor. It gives hydrogens, so in a solution with water it will become H3O plus and the conjugate base will be left, which is whatever you started with without the H. And we've talked about conjugate acid-base pairs, whatever you started with and whatever you're left with after the reactions happened, and both those conjugate acid-base pairs only differ by one hydrogen ion. When we're talking about strong acids, what makes them strong is because they donate lots of hydrogen ions into the solution, and that's because they fully dissociate. When we put HCl into a solution of water, immediately it dissociates completely. So you won't actually have any HCl together in that solution. All of it will be hydrogen ions and chloride ions. Whatever the concentration of that acid is that you put into water will equal the concentration of these two ions. Where this doesn't happen is in diprotic acids. For example, sulfuric acid is H2SO4. In that case, if you had 1 mole per litre of sulfuric acid, you'd have twice as much, 2 moles per litre of hydrogen ions, because every molecule of sulfuric acid has 2 H's. The same happens for strong bases like sodium hydroxide. It will completely dissociate into sodium ions and hydroxide ions. So solutions like that will have a large concentration of hydroxide ions, making them basic. Our strong acids and bases conduct electricity well. If you remember back to our atomic unit, something will conduct electricity when there are moving charged particles in the substance. Those charged particles could be ions, or they could be mobile electrons, as in metal solids. So in these solutions, because we've got a lot of ions present in the solution, it will conduct electricity really well. If you put some wires into a solution of a strong acid, connect it to a light bulb, the light bulb will glow brightly. Whereas with weak acids, and these are generally all our carboxylic acids from our organic unit, all the organic acids tend to be weak acids. Instead of fully dissociating, they partially dissociate. So we use this equilibrium arrow now to show that there is some of this present as well as some of this present. In fact, with weak acids, mostly it'll be this, maybe 1 in a million particles or less would dissociate. So as a result, we end up with a lot less hydrogen ions in these solutions, and so the pH is going to be closer to 7 than 1. Strong acids having lots of hydrogen ions in the solution will have very low pHs. Weak acids will have much higher. So if we had a 1 mole per litre solution of an organic acid like this, its pH may be 5 or 6, whereas 1 mole per litre solution of an acid like this, its pH may be around 2. Because there's not many charged particles in one of these weak acids and base solutions, conductivity is poor. So if we hooked up a light bulb and put it into a solution of a weak acid and base, it would glow brightly because there are some free moving ions, but much dimmer than these strong acids or bases. When we're talking about concentrated and dilute acids, that's a different concept altogether. That's talking about how many particles per mole of water, or moles per litre, concentrations. So something's very concentrated when it may have 6 moles per litre, whereas something's dilute when it may have like 1 mole per litre. When they ask you to draw graphs showing, say, a weak acid reacting with something like magnesium as opposed to strong acids reacting with magnesium, if we had the same strength acid and the same amount of magnesium, eventually the hydrogen gas that would be given off by both of them would end up being the same. However, we'd get there a lot more slowly with a weak acid. Now, what's happening when a weak acid reacts with something like magnesium? Remember, MASH, metal plus acid, makes salt and hydrogen. So in that reaction we're losing hydrogen, we're losing a product of hydrogen. And as a result of hydrogen being lost, this equilibrium's now going to favour the right. So more of this acid that's undissociated will split up and be dissociated. So over time, when one of these weak acids is reacting, more and more of it will dissociate as a result of a reaction like that. So even though there's less hydrogen ions available at any one time, eventually more and more do become available, and that 1 mole per litre will end up being all used up if we have excess magnesium. And that about covers strong, weak, concentrated and dilute acids and bases.